Can a 16-year-old understand quantum teleportation? Well, I'm here to tell you that the answer is a resounding yes. And it's not just about the teleportation. It's about grasping the mind-bending world of quantum theory. You see, quantum theory is like a secret club, a fascinating realm that most people never get to explore. But what if we could open that door to teenagers? What if we could give them the keys to unlock this incredible universe? Imagine a group of curious teens delving into the mysteries of quantum mechanics. That's exactly what happened at the University of Hertfordshire, where a group of young minds embarked on a journey into the quantum realm. This wasn't your typical summer camp. It was a week-long adventure into the unknown, guided by the brilliant minds of David Merriman and Bob Kowick. These researchers have developed a unique approach to teaching quantum theory using pictures, not just equations. And it's not just any pictures. These are spider diagrams, a rigorous graphical calculus that is mathematically equivalent to the complex Hilbert space formalism. In other words, these pictures are the math. Now, you might be thinking, how can pictures teach quantum physics? But here's the beauty of it. These diagrams provide a visual language that allows students to reason directly about quantum processes. It's like seeing the abstract world of quantum mechanics come to life. And the students loved it. They were engaged, asking challenging questions, debating, and collaborating. Imagine that, teenagers willingly solving complex quantum problems. The highlight? When a brave student stood up and explained the entire quantum teleportation protocol to the class. That's right, a 16-year-old breaking down quantum teleportation. It's a testament to the power of this visual approach. Traditional teaching methods often make quantum theory seem inaccessible, but this program proved that with the right tools, young minds can grasp the seemingly impossible. What I find truly fascinating is the impact this could have on science education. We often assume that certain concepts are too advanced for high school students, but this experience challenges that notion. It shows that with the right teaching methods, we can ignite curiosity and understanding in young people. It's about making complex ideas relatable and engaging. Personally, I think this is a game changer for how we introduce advanced topics to students. It's not just about the content. It's about fostering a love for learning and exploration. The students' feedback speaks volumes. Even non-science students found the program captivating, understanding quantum teleportation and the differences between classical and quantum physics. This wasn't just a lesson in physics. It was a lesson in curiosity and the power of innovative teaching. The joy and excitement in the classroom were palpable, and it's a reminder that learning should be an adventure. We should be inspiring students, not just teaching them. So, can a 16-year-old understand quantum teleportation? Absolutely. And more importantly, they can understand the wonders of quantum theory. This experiment proves that we shouldn't underestimate the capabilities of young minds. With the right approach, we can unlock their potential and open doors to incredible scientific discoveries. The future of science education is bright, and it starts with embracing innovative teaching methods. Stay tuned, because the next generation of quantum physicists might just be in a classroom near you.